our X, the number of boys, is 239. Best point estimate would be 239 over 291. So 0.81821. It's approximately. All right. Part B uses sample data to construct a 99% confidence interval estimate of the proportion of boys being born to parents using the Y-sort method. All right. So our confidence level is 99%. So that means Z sub alpha over 2 is 2.575, which is what we got earlier and also what we used in the last problem. And we want to calculate E is 2.575 times the square root of 239 over 291. Okay, 291 minus 239 is 52 over 90, 291. This goes over that too, and this is 291. Okay, so as before, let me clear my calculator. I'm going to start with the square root. I'm going to put parentheses around my 239 divided by 291. Close it, then times 52 divided by 291, and this is in its own set of parentheses. That whole thing divided by 291, and then close parens for the radical. And press enter, and then multiply that answer times 2.575. So I'm getting 0.0578. So you want to take it out 3 significant digits, okay? All right, so this time I'm going to use the fraction since I ran into trouble. Minus 0.0578. 239 over 291 plus 0.0578. Okay, 239 divided by 291 minus 0.0578. I get 0.764. And 239 divided by 291 plus 0.0578 and 0.879. Looked like the book didn't use the exact number. They got 0.763. Okay, I wouldn't worry about that except on the My Math Lab when you're doing it there. I'll show you how to do it with technology as well. Based on the results, does Y-sort method appear to be effective? Why or why not? Well, if we look at the, go back to the previous, the proportion that are boys is actually over 75%, over 3/4. Somewhere between 76% and 88% are boys, which is a lot larger than the 50% result that you would get normally. So that's pretty good. Now let's do this problem, number 18, using the technology, using the calculator. So let me go down here and open my calculator. move my window over. Maybe not. I want to keep it where it is. Okay, okay, so let's go to clear. Okay. All right, so we want to do number 18, the problem we just did using the technology. So what we do is we go to Stat, and we scroll across now to Tests. Okay, now we have a number of tests, but what we want is actually an interval. Interval means confidence interval. So let's go down. We have a Z interval and a T interval. Those are not what we want. We don't have two samples. Alright, what we want is the one proportion Z interval. We're doing a proportion, an estimation of a proportion with a confidence interval. So that's the one we want. So I'm going to click on Enter. Okay, so the first thing they ask for is X and N. X is 239. They had 239 boys born out of X is N rather is 291 babies. Confidence level, we want 0.99. Then we go down to calculate. Okay. All right, now through the technology, I can see how they came up with 0.763, 0.879. Whereas when I did it exactly with the fraction, I came up with 0.764. So you may want to check your work with the calculator before you enter it on My Math Lab. Looks like they're using the calculator for doing their estimation. Okay, let's move to number 20, and we'll do that one only with the calculator. So in number 20, when Mendel conducted his famous genetics experiment with peas, one sample of offspring consisted of 428 green peas and 152 yellow peas. So we have green, yellow, 428, 152, so a total of 580. We're going to find a 95% confidence interval estimate, a percent of yellow peas. Okay, and that's in part A. So let's go to the calculator. I want to go to Stat. I want Tests. I want to scroll down to the one proportion. Oops. Went too far. Way too far. I want A. There we go. Okay, so I'm going to enter. Okay, this time my X, I have to put in the number of yellow peas, 152. Total number of peas, remember we had to add them, so 580 I believe it was. We're asked for the 95% confidence interval, so we're going to calculate. And notice that this uses the interval notation. So 0.226 to 0.298. Or we could write it the way we've been writing it. Okay, so in part B, based on his theory of genetics, Mendel expected that 25% of the offspring peas would be yellow. Given that the percentage of yellow peas is not 25%, do the results contradict the theory? Why or why not? Well, if we look at 25%, and actually they did ask for this as a percentage, and I didn't give it as a percentage. Be careful of that in my math lab because it will count it wrong. What we note is that 25% is in this interval, so does it mean that the results could? No, they certainly don't. They certainly agrees with is in there. So no, this does not contradict Mendel's belief that it was 25. So so it turns out that true percentage could easily be 25%.